In this video, we're going to explore calculation operators in Excel. Now, we don't have all the same symbols that we would use in math on a keyboard, so we have to have some sort of adaptation. Addition is still plus, subtraction is still a minus sign, but when we get to multiplication, division, and exponent, the symbols change. So multiplication becomes shift and then 8, and it gives you an asterisk. The division is a slash, and the exponent is this little hat symbol. So when we want to do calculations in Excel, we always start with an equal sign. Equal to 4 plus 3, and it will automatically evaluate it. If we want to do subtraction, equal to 16 minus 2 should be 14, and it evaluates it as 14. Doing multiplication, equal to 5 times 6 should be 30, and it evaluates it as 30. Equal to 12 slash for division by 2 is equal to 6. When doing the exponent, 2 exponent 3, we use the hat symbol. Notice that I forgot the equal sign, so it didn't actually calculate it, just showed what the formula was. Equal to 2 exponent 3. And the exponent represents repeated multiplication, 2 times 2 times 2, which is 8. 2 times 2 is 4, 4 times 2 is 8. That's the other way of looking at it. Rules of BEDMAS. Well, it could also be represented as PEDMAS with a P. Generally speaking, in mathematics, we'll look at this as the order of operations in which something is done. You will do the stuff inside brackets first, then exponents, then division, then multiplication, then addition, and then subtraction. So how would we end up doing an expression like this? Well, we start with an equal sign. Equal to 5, and even though we don't see it, there's multiplication happening between the 5 and the brackets, times 2 plus 3 minus 20. What I would encourage you to do is try and figure out what this will be before we press enter. What will the value actually be? So, pressing enter, we end up having 5. So what exactly happened here? Well, it did the stuff inside the brackets first, evaluate 2 plus 3, so 2 plus 3 would be 5. And then what it would have done is 5 times 5 is going to be 25. And 25 minus 20 is 5. So that's one way we could look at it. Now, what do we end up doing below? This is a little bit more complicated, isn't it? Well, let's just try and figure out what will happen if we put in 6 plus 8 divided by 4 minus 2 plus 1. Is it going to give us the right answer? Gives us 7. Which one is right? I've put two different ones here to the side. Well, the way math is written is that this 6 plus 8 is supposed to be done first, and this 4 minus 2 is supposed to be done first before we do the division. So how would we end up writing that so that it actually evaluates it properly? We need some brackets. Equal to the stuff on the top, 6 plus 8, divided by the stuff that's on the bottom, and it needs to be evaluated, so we need brackets on the bottom, 4 minus 2, close off the brackets, and then we do plus 1. And what we get to see here is, this is what's happening. 6 plus 8 is 14, 4 minus 2 is 2, 14 divided by 2 is going to be 7, 7 plus 1 is 8. Well, I've created a question or an expression which comes out to both nice answers. One of them is right, and that's the one with the brackets. You see, when we're doing things in Excel, we don't have that option to have two lines or one numerator and denominator, or if we did, it becomes more complicated. So we have to learn to work with brackets on a single line. Let's take a look at how we end up doing the next question. Again, I'd encourage you to try and do this question on your own and see if you could figure it out without using Excel. Equal to bracket 2 times 6 minus 4, exponent using the hat symbol, 3. And what's going to happen here? It's going to go 2 times 6 is going to be 12. 12 minus 4 is 8. And 8 exponent 3. That's 8 times 8 times 8, which will give us 512. When we get down to this question, how do we end up representing pi? Well, sure, we could put in equal to 3.14 times 4 exponent 2, and it'll give us a value. But I'd just like to emphasize that technically pi is what we call an irrational number. An irrational number is a number that cannot be represented as a fraction. Not be represented as fraction. So what we could also say about pi is that it is a number which has non-repeating decimal places. A fraction would be something like 1 over 2, that's 0.5, or 3 over 4, which is 0.75. Those are what we call rational numbers. Irrational numbers, we can't represent them as a fraction. Therefore, we create symbols. So two irrational numbers that we should know are pi, and as you get into higher level mathematics, possibly grade 12 and finance, this other one, e. So how do we end up representing this in Excel? We actually have something called a function equal to pi. And we don't have anything going into this function, but what you do see is that if we put in equal pi with parenthesis, it ends up outputting what pi is. So if we wanted to go back up here and change this, equal to pi, open close brackets, times 4 exponent 2. And it will calculate it more accurately because it's not dropping the digits, or it's not dropping as many as what you and I would. It's going quite a bit more or quite a bit farther, probably up to 16. E is technically a number which is 2.71 something, blah, blah, blah. Again, it's an exponent, decimal places repeat forever. And it could also be represented exp bracket 1. It's basically doing e to the exponent 1. And there's our 2.782818. And again, those decimal places repeat forever. I think if we're looking at pi, the world record for memorizing pi digits, number of digits of pi, is I think either 40,000 or 80,000. Moving on. By the way, I will expect that when you complete calculations that do involve pi, that you are using the pi symbol, or the pi function, because it's just more accurate in its better form. Let's take a look at inequalities. So these here represent inequalities. What are these? Greater than, less than, greater than or equal to, less than or equal to, and not equal to. So these are the representations that we use inside of Microsoft Excel. So let's just come up with a number, 5. And if we want to try and create a Boolean value, this is something which returns either true or false. So is this number greater than 5? Is this cell greater than 5? It's coming up false. What if we change this to 6? Well, we hope that it should be true. Yes, because 6 is greater than 5. What do we have? 4. So this is strictly greater than, which means it's not equal to. 5 will return false. Anything greater than 5 will return true. What about less than? Well, equal to, less than, what are we looking at? This number less than 5. We'll try the same thing. Why not? Is this less than 5? False. Is this less than 5? Well, it's true. So let's just keep on going with this idea. Equal to, greater than or equal to, greater than or equal to 5, equal to this value here, less than or equal to 5, and this one is going to be equal to this cell, not equal to 5. So let's just take a look. If this number is greater or equal to 5, then it should return true. Let's just fill in 5 and see what happens. Well, is this number greater or equal to 5? Yes. Is this number less than or equal to 5? Yes. Is this number greater than 5? No, it's not. Returns false. Is this number less than 5? No, it's false. Is this number not equal to 5? And it's false. Any number other than 5 will return a true value. 8, 7, 5, anything but 5. So Boolean operators are and, or, and the Boolean value is true or false. This plays a part when we start doing conditional statements. And a conditional statement is something that has if. So an example of, let's just take a look at, we'll put in a number here, 10, equal to, if this is greater than 5, then we do true. And if it's not, we do false. So this is greater than 5, so it returns true value. While it might not seem apparent of how we're going to use this, this can be extremely useful when trying to look at data from many different data sets, or data points, or many different rows. And this will be used a little bit later. If you don't understand this whole idea of using if, that will be explored a little bit further on down the line. But what I do intend for you to get out of this lesson is how these operators greater than, less than, greater than or equal to, less than or equal to, and not equal to work, as we will be using them in the future. If you have any questions about this, feel free to drop an email or post up into the stream on Google Classroom. For now, keep safe and thanks for watching.